I'm Topaz. I'm really excited to start today's track. I see we have a lot of amazing talks in store all through the day, so let's start. Today's talk will take us on a journey from the science and machine learning research into a working software in production. We often know where this journey starts, but we have uncertainty regarding how and when will it end. And I know the word research, it has a wide range of meaning, referring to different things in different companies. So in the context of this talk, I refer to the term research in order to describe data science and machine learning algorithms. Throughout this talk, I will use an analogy of mountain hiking to describe the process of machine learning adaptation into production. And we will make the required preparation for our journey to start, and we will face its challenges equipped with tips and methodologies that I will share today. The target audience, well, this talk is not only aiming for managers, but basically can benefit anyone who is engaged in AI development in any way. Each can adapt the main concepts that we'll describe in the day-to-day work. So let's start. First, a bit about my own personal journey. I'm a mother of two, and my professional journey began in the space industry with satellite imagery and physical table data. Continued to electrical engineering studies in the biomedical computer vision domain, onwards to semiconductors and inspection and metrology. My previous role leading algorithmic teams that develop an AI-based sports production for live real-time broadcasting, and currently as VP of AI at Voyage 81 in the beauty and wellness domain. So basically, different data domains, different companies of different sizes, well-founded companies, corporate startups, and each company at a different stage of machine learning adaptation maturity. And what I find in common is, regardless of company size and data domain, whenever we embark on a new research journey, we just face this challenge. And you can see that I put explore here, just facing the opposite direction, just to showcase that there is a balance where when we wish to explore more and more. Let's just try this one more thing. I came across this amazing paper. Let's just give it a go. Exploration is really important, but it tends to be unbounded. And when it is, it tends to drive us away to the opposite direction from our goal. And our goal, we aim for our data science and research to actually make it into production and meet the real world. And we don't just want to do it once, we want that to repeat and we want to deliver value again and again. And that's basically a non-trivial goal to have, and only 54% of all AI projects even make it from pilot into production. In today's talk, I will cover some methodologies that I find to be really helpful in improving both delivery and impact. So let's start the preparation for our journey into production. First, there are some items we'll need to cross off our checklists. So we need to make sure we find and identify our starting point. And your starting point is the maturity of machine learning adaptation in your company, because that will have a lot of influence on the complexity and length of our journey to the mountaintop. So is it a data-driven company when all decision making is based on data and analytics, an AI-driven company where the main product is some artificial intelligence capability? Did you already make it to a successful proof of concept based on machine learning, or are you already heavily invested in machine learning models in production, driving revenue to the company? So based on your starting point, make sure all stakeholders that you're involved with are aligned in the experimental mindset that is required for data-driven development. So back to the journey analogy, that is the pep talk you have with your fellow travelers when you're getting started for the climb. You need to make sure all start this journey with the right mindset for the team effort. And many times this educational step, it does not come smoothly. People work with software developers will in no way accept a software developer saying he released a new web page and he's only 97% confident that this page will actually load. What do you mean you're not 100% confident? Well, our machine learning algorithms are just a piece of software with a confidence tag pinned into it. So this stage is really important. It can be an offsite with your stakeholders or a presentation with an open discussion, whatever you can, in order to explain the experimental mindset, how it differs from regular software development, And basically, because otherwise people tend to move uncomfortably in their chairs if they are asked to put a lot of funding into a black box. So demystify it, explain how you make sure you reduce the risk, be transparent in your day-to-day work, and gain organizational trust. One more thing before we start a new journey, we must check for the weather forecast. We definitely should mind the weather because when it rains, it pours. And today's weather is rainy indeed, with market leaders being going through some cutoffs and layoffs, and companies are being asked not just to show profit, but not only the promise of growth. So basically, just the promise of growth is not good enough. We need to show profit. And if we'll take again the journey analogy, if you were walking on a really, really nice hike during springtime, that same path can get really, really slippery when it starts raining. So we need to quickly adjust our course. So you may feel like that at the moment with all that information regarding layoffs and cutoffs, but fear not. Fetch your umbrellas and let's do this. So especially when it rains, um, ever, but always, and especially when it rains, we need to make sure we have an impact. So regardless if you're in a management position, feature owner, data scientist, each in our own role can adapt in the light of those guidelines in order to improve our impact. So basically, we want to balance between incremental, smaller improvements with lower risk and the big swings. Those are the huge new features. They have a lot of more risk, but additional promise into them. So in machine learning context, incremental can be retrain the model you already have in production with a bit more data, tweak with the loss a bit, maybe tune your hyperparameters and thresholds. Those could be incremental improvements. They gain improvement, almost guaranteed to gain you improvement, but they can only take you so far. The big swing can be implementing a whole new architecture, a new model, this new risky research phase. And what we want to do, we want to balance the two. So let's take a look and in that image right here. So there are many ways to make it to the top. We can walk incremental step by foot, or we can take the big swing with a cable car right here. So basically, incremental is not always the safest way to go, and I'll explain why. While the big swings, they tend to take longer time and they require larger effort compared to incrementals, where you always deliver value faster, a value, some value, but usually smaller. The big swings are the differentiators. That's what differentiates us from competition. That's the amazing new big feature that no other competitor can achieve in time by the time that we'll release it. But incremental, on the other hand, may miss our end goal because they can only take us so far. So we want to balance and want to make sure we always plan to have at least one big swing project that we're working on. MVP mindset, minimal viable product mindset. Let me explain that with that image right here. So let's assume our end goal, what we want to release, it's a car. And it's a very large task, so we break it down into stages. But the problem with this approach up here is that each of those stages basically gain no value to the end user. So the user will have to wait for a very, very long while until they get what they want. So we may miss the market opportunity or lose the competition. With the MVP mindset, we make sure each step has some value. And we ask ourselves how we can release something even smaller that can create some impact. But I call that MVP mindset with end in mind because we need to make sure we keep pushing toward that end goal. Because our users, they will simply not stay satisfied with a scooter for a long while if they're expecting a car. So make sure not to settle down for incrementals only. Make sure you eventually deliver the big swing, the car. And in the context of machine learning, for example, if your end goal is a detection problem, maybe only solving localization first before you can really classify well enough has an impact of its own before you make it into a full detection. Okay, so we're done with preparations and we are now ready to hit the road. First, we should not start any journey without a plan. So plan your work and work your plan. If you're a project manager, feature owner, tech lead, epic collaboration is really important, and we need to do it well. Let's say that that distant mountain right here is our target. If this will remain our only defined target, well, I call that the mountain of two vague targets because it's too far away. poorly defined and introduces many uncertainties. And during the climb, you'll just get a sense of we'll never make it. It's just so far away. When the target is too vague and too far away, we just miss the feeling of progress. And if that will remain our only target, then this guy right here, he will take the turn to the beach instead of keep climbing. And we don't want to do that. So basically, we must set visible targets. And I know it's been argued that you cannot put time estimation on machine learning research tasks. They are too experimental, and you have so many unknowns. But in my experience, those huge tasks are the ones you do need to break down to smaller pieces. And for example, your epic collaboration can include an initial data exploration phase, literature review, developing the business metric, model development, evaluation, so on and so on. So break it down, and that will basically reduce the uncertainty of each stage and gain that energizing sense of actual progress. And in order to really make sure we progress with the visible targets and not lose our course, we need to make sure we have a compass. So we need to align with the product manager on our business goal really, really early on. Get that metric just right. What is success and how do we measure it? And now let's assume that we already experimented a bit and are convinced that this machine learning problem is solvable. And we by now have some basic idea on how and what building blocks of algorithms we need to develop. So basically we have the basic concept. For example, pre-process block should come first, then we will do some object detection, final localization, classification, then some decision block. So we have a basic concept with some kind of a plan to progress, but how we make it into a working software, what's the next step? So this one, that's for professional hikers only. Okay, I find this approach to be very useful to keep focus and improve progress. And I call that the test-driven machine learning. It's inspired by test-driven development. So basically, first, you want to set your business metric. And it's not only the success criteria. It's not only definition. It's actually coding and write it down the function that will evaluate the business metric. This really forces you to understand what kind of data you need in order to really be able to calculate that. Then you want to create the API of each block, build a pipeline. Each block right here, you should set inputs and outputs, and you want to be able to connect them. So API, no content yet. And then build unit tests for each block and evaluation metric of its own. So those unit tests, they will initially fail because those blocks, they do not meet performance criteria when you're only just getting started. But only at this point where you actually built the full pipeline, all the moving parts are connected right now, and you have the metric to evaluate each. Now you can invest into research and improve each block and iterate. And now that all moving parts are connected, you have a way to measure each one and the full pipeline. This enables you to identify release opportunities early. So you could iterate and improve and improve and improve. So you will identify release opportunities, reduce the uncertainty regarding to where you stand compared to your end goal. And in the context of validating new product ideas, it has been said that if you're going to fail, then fail fast. And we can adapt for that in our research phase as well. And what do I mean by that? We talked earlier about the importance of success criteria and the way to measure the success, our compass. But when you do that epic collaboration, it's not only important to set that acceptance criteria, that definition of done, it's also important to have a stop criteria. And what is that? Well, basically, many researchers can find themselves really digging into some problem and even a month of work being stuck with their head against the wall before realizing that is a wall right here. We hit a wall and we hit it a long time ago, but we just keep pushing and insisting on that specific course of action. So basically, we want to make sure we have the right indicators that will alarm us in time that we are about to hit the wall and that we hit the wall and we should stop, rethink, and reconsider our continued research. And it's really important that if you actually hit that stop criteria, and that stop criteria could be a time limit for the research combined with some performance threshold, something like that, or anything else. If you hit that stop criteria and you made a decision that you do not want to continue in that path, then document the reasons why. Why was it successful? Because if you will not document them, then one of two things may happen. The first thing, maybe you will repeat the exact same mistake again with same circumstances somewhere in the future. The second thing that may happen is that you will come across a different problem, different scenario with different assumptions, and you will say, no, we've tried that approach in the past and it didn't work. But basically, everything changed, that the assumptions that caused this failure are no longer valid, and maybe that will be the exact best course for you to take, but you just didn't record the failure reasons, so you can't tell. So make sure you document them to be able to get back on track as soon as possible. And some additional tips how we can boost our machine learning research with agility is we don't only break down to visible targets. When we do that epic collaboration, we want to make sure that the stories that we break that down into are contained in a week of progress, or in a week's time of work. And we don't only want to work on them, we want to make sure that they're in some way deliverable. So make sure even in the research phase, you open a pull request on a weekly basis. Yes, even in the research phase, because, well, I'm not sure how many of you did a code review for data scientists before, or machine learning researcher, but as a computer vision researcher, I was once asked to do a code review for a colleague when he finished working on a very big new feature, and tens of new classes, so many new functions. I had no part in the design of this research and the research of this feature. So it's insane. How can you code review that? You basically can't. So even during research, break down into smaller pieces that someone else can really give you some feedback about, finding your bugs and wrong assumptions earlier on. And I'll give you a hint. It doesn't have to be a pull request into the master branch. Not at all. It could be a side branch that you open a pull request to and gain that progress of someone actually reviewing it. And don't just open that pull request and leave it as it. Just make sure you merge it, because a pull request that is open for more than 2 weeks becomes unmanageable and irrelevant. So make sure it gets the right attention and is being merged. And peer review is not only important in the context of code, but also about assumptions and results. So share those with your peers and make sure you get review on those as well. So you will be able to get a sense that you keep moving in the right direction. So if you're using Scrum and sprints and you see the progress from one sprint to the other, or if it's a Kanban board where you see your tickets flow from in progress and verification done, that's energizing and gives you the sense that you're in the right course and you're getting there. One more thing that I find to be really important is basically data-driven research. And what is that? If we start a research with insufficient data, then we basically build something on really unstable and weak foundations. So this following approach, something that I came up with in previous company, took me a while to really get everyone in the right mindset in order to follow it through. But basically, let's say all the teams in your company are sitting down at the end of each quarter, planning the quarter ahead. Then only the algorithmic group should, at least that group should plan earlier on. So let's say in the middle of Q1, you should already have the plan for Q2, so you can immediately start the data collection and then cleaning the data, annotation that is required in order for you to be able in Q2 to really start meaningful research. And that can really just reduce uncertainties in your research, improve that research, make it much more productive, and just give you that shorter cycle of research. So that's a test for the experimental mindset adaptation in your company. How well can you plan the data collection ahead of the research? And if you aim, for example, for this new machine learning feature and you aim for it to work in day one for all possible users, all possible scenarios, anytime, anywhere, you will have a hard time to meet the quality requirements for all that and be able to deliver some value in a reasonable time. While in MVP, we ask ourselves, what is the minimal proposition that we can release that provides some value? In our case, we will ask, what is the smallest subset of data to validate the research and gain impact? So basically, sit down with your product manager and try to figure out what subsets of data can you aim that first release to. It could be a different type of user groups. So for example, the first release will only aim for early adopter users. The second release then will, the second version that you will release will then aim for a larger group of people, of users, or of scenarios. It could be different camera types, it can be different operating systems, and so on. So basically, you create focus between versions and you improve your ability to actually have some value released to a part of the users in a reasonable time. And especially important in B2B, but always we need to make sure we do not do a full rollback. And a full rollback is the horrible scenario where you already released the version in production, it's running this new machine learning feature, but it misbehaves because of data shifts or some unexpected scenario, and you will now need to roll back the entire version, not only this new feature, everything with all the new bug fixes and all the new features, and basically it cannot happen. You need to make sure that you have a turn off for this new machine learning feature, this new model only. So we definitely always want to avoid a full rollback of the entire version. It's costly, it hurts the user trust and engagement. And therefore, we must always strive to design a fallback for a specific new machine learning feature that allows us to disable just that feature without affecting the whole version. And in B2B, it might be done manually just for this one specific user, but optimally, you want to design an automatic fallback based on a calculated condition during the runtime. So it could be unreasonable predictions, exceeding runtime, assumptions that break, and you can actually code it and check in real time. Something like that that you could automatically decide to turn that new feature off. And by doing that, you also, it allows you to continue and collect data for this new feature and identify the source of the issues and then improve. One more thing I really like are inner releases. I found those to really just create shorter research cycles into production. And what is an inner release? An inner release says that you take now this new machine learning functionality and you make sure to make the plan of how you fully integrate it into a working software in production. It could be sitting with all the teams involved, the development team, the DevOps. It's already integrated into the databases, integrated to everything. So you have an end-to-end working software. Just don't influence the user just yet. Okay. So basically, you do all the calculation, you store them in your databases, but you don't show anything different to the user. So that's really can help you to start the integration in parallel to the research. So while your research may not yet hit the performance requirements, but you're getting there, you can already start the integration. And by the time you will be finished with your research, then only just releasing new weights and tweaking with thresholds will not be that big of a deal. So that definitely helps you to reduce risk, create shorter research cycles, you face the real world earlier, you gain organizational trust when everyone are involved in the integration and really understand what this feature does. You have the full integration and basically your foot in the door to really start to have a feel of real data and how this feature really acts. So yay, we are ready to release. And now what? One stage of our journey is over, but another begins just before we release. Well, it's always important, but especially just before we release, it's important to align expectations. Imagine that you were climbing that mountain for a while, and now you have that fantasy about the amazing view that you'll see when you get there. So align expectations. I'm a big believer in a release note, so make sure you write down those release notes and states the main impacts of this new machine learning feature, the improvements, but also the current model's limitations. And if you have remaining open issues and known bugs, make sure you write those down too. So that will really gain trust and everyone will know what to expect and what not to expect. And once we are in production, it's really important for us to understand how we do a rollout. So basically, we talked earlier about the data subsets table. That's a different table. The data subsets, they were addressing different versions. Each version really want to make sure you do the right product for the right subset of users, for example. This table is different. This table is about the same version being gradually released. So it could be one country after the other, one continent after the other. It could be gradual increase of your traffic. Either way, make sure you have a control group to compare to, that your dashboard and monitoring is ready, and that you store the data that you'll need in order to get a feedback of how it works in production, identify issues, improve, and basically get ready for the next release. And when you're finally there in production, don't forget, be an ML advocate. And what do I mean by that? Share analysis about this amazing new feature. Just raise awareness for this feature. It could be an email, share a dashboard, whatever you can, and celebrate the success with a happy hour or something like that. It's just as important to enjoy the success. So I really hope you enjoyed our journey together, and I wish you many successful journeys of your own with happy into production endings. Thank you so much. Please feel free to reach out via LinkedIn. I will be really happy to continue discussion and get your feedback about the talk. And I hope to see you all later today in my second talk about classification for regression, a bit more technical. Thank you so much.
Thank you so much for being with us here. There is a question.
In your opinion, where should be the focus for a new, unexperienced team that is just getting started? Well, basically, the most important thing is for you to understand your starting point. So that was one of the first slides, right? So the starting point matters. You need to understand what type of company, machine learning adaptation phase you are currently at. Let me get there. Sorry, so many slides. So it will be really, really different based on the stage. If it's an unexperienced team that is only facing the first proof of concept, or is it a new team with a company already have routines to regularly create releases into production? So if you already have another team that's released into production, basically it's important to study their methodologies, what works, what to make sure that you can replicate and where you can improve. But if it's your first proof of concept, then basically that phase of alignment with your stakeholders about experimental mindset is really important to make sure how you can create those routines inside your company to gain the data you need in order to create healthier cycles of research.